Alright, one of the questions I get asked commonly about, and it is kind of a hard concept to see, is this idea of carbocation rearrangement, specifically how to tell when it happens and what the product is. So I'm going to break this into two videos. The first video is just going to be a simple case of hydrogen and methyl shifts, and the next video will talk about more complicated things like ring opening carbocation rearrangements. So first of all, we need to ask ourselves, what's the driving force behind a carbocation rearrangement? And the driving force here is converting a primary carbocation or secondary into a secondary or a tertiary. So let's say we have this compound here. So we have 3-methylpentane and we have a carbocation located on the second carbon. And we want to ask ourselves, does carbocation rearrangement occur? And if it happens, is it a methyl shift or a hydride shift? And we typically focus on these because they're the simplest and the easiest to see, and they're pretty common. So in order to figure out if we're going to have a shift in which way it goes, we look at the carbons that are beside our carbocation. So here, this carbocation, this would be a secondary carbocation. And to the left, we have a hydrogen, a methyl, and an ethyl. And to the right, we have 3 hydrogens. Now, we can get a shift from either one. The question is, which one is more likely to occur? So let's say we shift a hydrogen over. So what we're going to do is we're going to replace this positive charge with one of the groups on this carbon, and we're going to put a positive charge on that carbon. So if I do that, if I swap a hydrogen, I'll end up taking this secondary carbocation and making it into a primary carbocation. So this doesn't work. So let's say instead of swapping the hydrogen, we swap the methyl. So take it, and I'm going to take my methyl group, I'm going to replace it, and I'm going to put the carbocation on the carbon I just swapped with. Now if I look at this, I went from a secondary to a secondary. I haven't gained anything. So because I haven't improved the stability of the carbocation, I don't get a shift. But what happens if I take the hydrogen and swap it over? So 1, 2, 3, 4, 5. And I'm going to take the hydrogen, I'm going to put it here, and I put a carbocation here. Well, now I've got a tertiary carbocation. So I've gone from a secondary to tertiary. This will happen given sufficient activation energy. So to figure out if carbocation rearrangement occurs and what happens, first thing we need to ask ourselves is it possible in principle to make more stable carbocation? So if we have a primary, we can definitely switch to secondary or tertiary. If we have a secondary, the only reason we can get a shift is if we go to tertiary. And if we start with a tertiary carbocation, those are the most stable, so we don't really expect to see anything. Now, the question is, what shifts if we do have a shift? Well, to do that, we identify what can shift. So we have hydrogen, methyl, and hydrogens over here. And we just draw them out, we guess and test. So we take one of the groups and replace it with a positive charge and put the positive charge on where we're doing the swap. In this case, we made a primary. This didn't do us any good. Moving this methyl group gave us a secondary. We already had that. But moving this hydrogen definitely shifted us to a tertiary. And so this would be the carbocation we finished with. Now, there are definitely more complicated examples of this. So stick around for the next video and we'll talk about more advanced carbocation shifting techniques. But in terms of just like Organic Chemistry 1 and most basic problems, this is kind of your introduction to carbocation rearrangements, and this is the line of reasoning that we would follow.